And let's welcome Daniel O that will present a talk about scalability metrics that are different than CPU or memory. So how to configure, for example, scalability for an event-driven autoscaling app. Welcome to Daniel O.
Hello, everybody. Thanks for good introduction, Serena. And good morning, good afternoon. Depends on where you are. So I'm basically based in Boston, United States. It's an Eastern time zone. It's almost 8:40. And then I believe some people are actually afternoon is try to call it a day, and then some go to grab some beer or some stuff. But once again, thanks for having me. I'm so happy be here. And then, yeah, I'm so excited today.
Okay, so thank you. You work as SRE, a senior principal developer advocate for Red Hat. So the stage is yours. Have a nice talk.
Thank you so much. All right, everybody. So yeah, once again, thanks for joining my session today. So I'm going to talk a little bit about next 30 minutes with some really interesting demo around event-driven auto-scaling through Apache Kafka source and the KEDA and the Knative integration. It's all about serverless. So just quick introduction of myself. So I'm working for Red Hat as a developer advocate, and then specialized in cloud and native runtime, like a Spring Boot Quarkus, and Java technology and JavaScript and so on. I've been spending a lot of time to bring Java workload into Kubernetes, specifically serverless service mesh and GitOps practices. Because I'm also responsible the Cloud Native Computing Foundation, aka CNCF ambassador, which gave me a lot of a chance to have some conversation with not only developer but also SRE and the platform engineers and DevOps engineer in terms of building their cloud native architecture and then make it better and a greater application portfolio running on Kubernetes with the ecosystem. Here's my quick contact information. You can follow my Twitter, and then you can subscribe my YouTube channel, Daniel030, and then you can steal any example, learn and develop application, my GitHub repository as well. Here's my book and dev zone stuff as well. All right. So this is some fundamental thing, how to auto scale your application on top of the Kubernetes. So one of the beauty of the Kubernetes, it provide auto scaling, self-healing, and replication. There are a bunch of the Kubernetes stuff. And we're going to really talk about auto scaling architecture on top of the Kubernetes. For example, we have a multiple microservice application running on pods on kube cluster. As an example here, we have like an inventory application, catalog application, and auto application, regardless of what kind of runtime you're going to use, more Java, JavaScript, Node.js, even Python, and the other stuff as well. And then in order to set it up auto scale, you need to create a horizontal pod autoscaler, aka HPA, for each resources. For example, deployment and the min-max, and then like a utilization based on your CPU and memory, etc., which is really cool. However, what about your real production environment? For example, you need to address your incoming network traffic from external services out of the Kubernetes cluster. For example, you have somewhere out there like a Kafka cluster, an infrastructure layer, or you have a dedicated infrastructure layer for your logging, tracing, and metric based on Prometheus, or even you can integrate or communicate with your external public cloud services for your metric data. For example, AWS, the CloudWatch, and then Azure Monitor, and so on. So how to address your event-driven application to consuming millions of telemetry data or the messaging data or messaging storming from external services? How do you do that? So in order to do that, you maybe think about, oh, we can add like a Kubernetes custom metric just like that to build your own auto-scaling infrastructure. So this is still looking good. However, one big challenge for you when you build a Kubernetes custom metrics, you can create your custom metric adapter for each external service. For example, AWS CloudWatch, Prometheus and Azure Monitor, there is no direct metric adapter for your backend Apache Kafka cluster. But one of the big challenge is you can only enable just one metric adapter at a one time. But however, your microservice application may be consuming processing from event-driven metric data from Apache Kafka, but the other application actually needed to processing the Amazon Cloud Watch. For example, here the catalog actually consuming some of the data from the Azure Monitor, and then all the services needed to be consumed in the processing for your Apache Kafka and Apache Kafka source, something like that. How to manage the multiple event metrics and then event-driven autoscaling based on its external services. That's why the KEDA was born and designed to address this kind of challenges. So KEDA, literally Kubernetes event-driven autoscaling, pretty simple, that simple. I believe a lot of people are already interested in or have heard about before what KEDA is. As long as you are interested in developing reactive programming or event-driven application, specifically like a messaging broker or a Kafka cluster, regardless of on-prem Kubernetes or public cloud like Azure function, etc. So here's a bunch of the bullet points. I'm not going to go through every single detail, but the one interesting is KEDA actually provides more than 50 built-in scaler, which allows you setting up your external services, multiple external services for event-driven application handling. You can actually install KEDA for with the operator or a Helm chart. With the KEDA, you can pretty much better the auto-scaling infrastructure architecture. Just the example here, you don't need it to HPA anymore. You just create the scale object for your standard Kubernetes resources, for example, deployment here. And then each scale object specify which resources you're going to trigger based on your external service like Amazon Cloud Watch and directly Apache Kafka and Prometheus and Azure Monitor and Azure Pipeline and so many things that you can actually enable that. And one of the more beauty of the KEDA, you actually trigger the HPA Horizontal Pod Autoscaler because the KEDA only manages scale 0 to 1, 1 to 0. That's it. But in the real case, you need to scale out more than one pod, which means maybe 100 pod, 1,000 pod for handling your event streaming. So that's why KEDA enable your application actually scale out to more than one based on HPA. So what about this serverless autoscaling? So a lot of people actually wanted to move forward to workload based on serverless, for example, Amazon Lambda or Azure Function, Azure Google Function, etc. However, what if you could do that the same capability on top of the Kubernetes? So that's why Knative project was designed and it handled this kind of needs. So Knative allows developer and SRE team manage and deploy and build your application on top of the Kubernetes with almost exactly same behavior like a Amazon function and Amazon Lambda thing. So once you deploy application as a pod, that will be scaled down to 0 if you don't have any network traffic for the next few like a second. The default compilation, which will be just 30 seconds. So some people are actually really wondering what big differences between KEDA and Knative. So some people say, yeah, KEDA maybe is some kind of competitive tool or project over the Knative. The answer is true or the yes or no. So today I'm going to really showcase how to integrate KEDA and Knative for your event-driven autoscaling on top of the Kubernetes. But here's a few blue points showcase what differences between KEDA and Knative. So KEDA basically just focus on scale up and down based on event-driven metrics, event-driven data, standard Kubernetes resources. For example, you don't need to rewrite or redeploy or recreate your existing standard Knative resources, like a deployment or stateful set or something like that. However, Knative, you need to rewrite your resources based on Knative services resources to deploy your application, which means I already deployed my like a Java application with the, like using deployment resources. In order to deploy your application as serverless using Knative services, you need to create a new YAML file for Knative services. That's the one of the challenge for you. However, KEDA, you don't need to do that. Just you just set up, create a scale object. It allows to managing a scale up and down based on event-driven data. And then there are a bunch of the other way, like a push and pull model, because the Knative services has its own autoscaler rather than using fundamental HPA. And then I'm going to really showcase during the demo. So today I'm going to showcase actually two different demo. Actually, maybe I'm going to showcase one more thing if I have more time. So what we're going to do is we're going to so let's say we already have some Knative we already use in Knative for event-driven streaming. And also, we already have Knative designing for your auto-scaling stuff. And one of the things is, so in order to use cloud event with the Knative, you need to rewrite your existing application. So what is a cloud event? In case you never ever heard about it before. So when you develop React application, you can actually define multiple types of event messaging, for example, JSON format or binary or the protobuf. So it depends on what kind of application platform you're going to use or what kind of messaging infrastructure you're going to use. So the problem is maybe you need to transform or rewrite your messaging format to understand that platform. For example, you really prefer use your JSON format event-driven messaging. However, consumer side, they're looking forward to consuming like a binary. How do you do that? That's why you have some integration tool or some kind of middle layer integration platform to transform this message to that message. However, cloud event is more polyglot and a flexible messaging format. You can actually use multiple different types of messaging format, and then they automatically rewrite and rewrapping your messaging format for your multiple cloud platform to address the messaging programming. So Knative actually use cloud event. So as long as you wanted to use a cloud event, you need to add some kind of business logic or method, change the return type or method format based on the cloud event. So this is your first demo stuff. Now let's get into the demo. How do we deploy application to addressing event-driven messaging? So I'm going to start my presentation. And here's my Kubernetes cluster. So I'm going to use the Red Hat OpenShift cluster based on Kubernetes, the latest version. So I already installed KEDA and then serverless based on Knative, and the KEDA is I'm just using operator. As you can see, the KEDA operator installed, and then here's the KEDA some of the stuff, and then here is my Knative namespace. As you can see, so there are a bunch of autoscaler. This is what I mentioned earlier. The Knative project uses its own autoscaler rather than the horizontal pod autoscaler. And this is what you can see here. And I just edited Knative eventing to process the eventing message. There are a bunch of the pod already deployed. And then one of the things is there are KEDA controller here to integrate your Knative eventing. And also the Kafka controller here, because I'm going to deploy Kafka topic. The Knative Kafka controller is pretty easily integrate your Knative eventing with your Kafka source or sync, etc. So here's my first example application is I already deploy the Kafka topic and the zookeeper for like a HA capability. And then I deploy Quarkus application, which is my Java application. Is to make it pretty easier integrate your reactive programming and consuming processing some event messaging to and from Kafka topic. And then I already create KEDA scale object. That's why you can see the HPA automatically created. And then you can actually find here scale object, and you can see Kafka scale object. You can see there are, you can go to YAML, and then it showcase the bunch of thing, and then the Kafka scale reference object. Here is the deployment name, Quarkus EDA demo, and then trigger from our Kafka Bootstrap server. That's pretty easy to create the scale object. And then back to the topology view, once again, the deployment Quarkus the EDA demo. So now I'm going to go to my ID tool. This is actually Kafka cluster. They already included the one of the best script to performance test. So I'm going to run this performance run the performance test bash script inside already existing in Kafka cluster. I'm going to using the Kubernetes job. It create the 5 parallel job here. Here we go. And then I'm going to use the topic name. My topic already created there. And then I'm going to create, generate the 1 million the dummy record to generate new record and sending to topic. And then my Quarkus Java application will consume that 1 million. It technically 5 million because 5 jobs will be created, and each job create 1 million record every single second, and then send it to topic. And then Java application based on Quarkus will consume that 5 million event messaging. And then we're going to take a look at that, how fast KEDA will scale out my application based on event driven. It's pretty much fast than like just using HPA based on CPU realization. So I'm going to copy this whole YAML stuff and back to here. You can actually run kubectl command line, but the OpenShift cluster provided a bunch of just great graphical UI. I just create it back to the topology view. And now you can see the new job just created here. And then the new job is a file is created. You click the one of the build logs, and it will pop up new record just created. And back to the topology view. And then now you can see your the pod will created. But this is just general pod, not serverless. So you can see the pod already scaled out to 4, and then now it's scaled out 8. And when I now click on one of them, you can see the Quarkus logs, and then so Quarkus is really busy to consume and processing the application just like here. So this is how KEDA works, but not serverless application technically. And then I move to one of the KEDA, the Knative project. I already created some my Kafka topic, just exactly the same project. And back to my application. Let me take a look at that, my new application here. And then my application, I already created some very simple, like a Java application based on like a cloud event, the JSON format. It's pretty just dummy stuff. And then I just need to set it on my application properly. This is one of the great things because Quarkus actually provide a reactive programming integrated Kafka cluster here. So based on small RIDE project, you can actually integrate and enable Kafka stuff pretty easily. So and then back to the application, I just set it up. So my namespace, which is Kafka KEDA, just like here, Kafka KEDA. And then the integrate image registry where I need to push my application container image into registry. And then the one disk compilation, which make me just deploy my application as Knative, which is pretty awesome. So let me try to make sure I'm logging the right project. Kafka Knative. And then I'm going to try to using my Quarkus CLI command line. You can actually using Maven or Gradle. And once I run Quarkus build command line, it automatically packaging my application like a jar file, and then containerize my jar file based on the Docker file, something like that. For example, when you created the Quarkus project, it automatically created a Docker file in case you want to packaging application like a container image for JVM, and then like a native, because the Quarkus enable Java developer to packaging native executable file running on like a just executable file, like a Windows executable file. It's pretty much smaller and faster rather than the ordinary Java file. It pretty much good for serverless application, but I don't have, so it takes a little bit longer to packaging application. So that's why I just try to use a Java file for this today. But once you add like you enable like a Quarkus native build is true, which allows you packaging native executable in the reality. As you can see, I just packaging application based on Docker file, and then I just pushing my image into, I satisfy my integrate containerization inside the OpenShift cluster. Now you can see the build success, which means when you go back to topology view, you can see new application just coming up right now. So my Quarkus application running, and you can see go to here in the same application running in JVM. When you deploy application as a native executable, it will show up like a native. And then here's the Quarkus version and a bunch of the capability I already enabled, like a Kubernetes deployment and reactive application, and also the messaging, and then some Kafka thing as well. So that's the one. And now I'm gonna go back to add the Kafka source. This is a really cool thing to enable your Kafka stuff. So in order to enable your Kafka like a consuming message, you need to set up like a bunch of the configuration. But with the Kafka source, the CR, which allows targeting your Knative services. So you can see you can target Knative services. So which means whenever you are sending your messaging, event messaging to Kafka source, and it automatically reporting to your Knative service with this Kafka source YAML file. And I just save it, create it, and now you can see attached to that. In the meantime, my application scale to down to 0, like a terminating. It default compilation 30 seconds. And then I'm gonna just make a little bit interesting here. I'm gonna make it this pod with the Quarkus stuff, because in reality you can have a multiple application. Now you can see the pod is scaled down to 0. So now I'm going to try to run the same job file just like run into the KEDA. So now you can see and figure it out how fast this my Quarkus application scale up, because it's scaled down to 0, just like Amazon Lambda. And I just run my application here, and then you can see the record is just created every single second. And then back to the here, it will scale up in a minute, because the application to go to Kafka topic, and then it will consume my application in the end. And then in the meantime, let's go to the other project. This is really I wanted to showcase today. So just back to my slide deck and give us a moment. So how to handle your serverless or scaling based on event driven? Because the Knative will actually scale up and down from 1 to 0 for your serverless application. However, what if you could have millions of events sourcing from like an external service, for example, Kafka or like a public cloud services into your application? It's not good enough just scale out to one pod. It's more than like 100 pod, 1,000 pod along with your network traffic. So that's why we can actually have a sandbox project integrate KEDA and Knative. It's not like a competitive project anymore. As long as you want to use on-prem Kubernetes for your serverless application development based on Knative, and you can also make it better performance and a better event-driven architecture with the KEDA and Knative. Just like this is one of the beauty of the open source project. Maybe you already know open tracing project to manage your tracing capability. You can also have open sensors to managing like a telemetry data from IoT edge, as also like an application itself. Sometimes you need to choose open sensors or open tracing. However, the new project actually combine two great projects as open telemetry. So this is one of the beauty of the open source project ecosystem. So anytime we can have more capability as long as we have more needs from end user community. That's why this same project was also came out. So KEDA actually autoscale Knative eventing infrastructure at this moment because I set it on Knative eventing here. And in the end, we're gonna looking forward to a new feature. KEDA will scale out Knative services directly without Knative eventing, which means we just eliminate one of the middle layer. It will give us more high performance and reliability in the end. So with that architecture, it's a little bit changed there. So previously, here you can have the Knative project. Actually, the Kafka keep sending messages, the Kafka source, and the Kafka source is sending cloud event messaging, like a polygraph. No, it doesn't matter what kind of event messaging format you're going to use, JSON, product, binary. And then in the end, your Knative service, like a Quarkus application, scale out from 0 to 1 because the Knative will actually pushy and decide now is the right time to scale out. However, with this new architecture, KEDA actually keep monitor and keep scrapping your metric from Kafka cluster and decide to scale out your Kafka source itself. It's not only scale out your application itself, but also scale out the event-driven infrastructure as well. So it's a pretty much a faster scale out, and then in the end, the Knative actually scale out the applications. It pretty much is a two-layer scale out at the same time based on your event-driven metrics. So let's go back to my demo environment, and then I'm going to try to change my application to KEDA Knative. It's the same thing. And then back to my terminal, and I'm going to try to change my Kafka, KEDA, and Knative. Change my project, and then back to my application, and then I'm going to change my to application property. So name process Kafka KEDA, and also one of the beauty of the Quarkus, actually you can set it up your Knative configuration like a min-max stuff. Here we go, and then I just save a file and then back to the terminal, and then let's try to one more time build my application. It's one same behind the scene, the packaging jar, and then create a container image and then push that image into specific container registry, which we're going to use, integrate container registry inside OpenShift cluster. You can also define your personal or corporate container registry, for example, Docker Hub or Quay.io or Google Container Registry or your corporate container registry. And then Kubernetes will pull out that container image as a Knative service. You don't need to write down Knative YAML file, or you don't need to use Docker CLI and so on. So as a developer standpoint, or even Kube developer standpoint, I just need to run my Maven command line, which allows me packaging application and a containerized image and push that image, and then in the end deploy to Kubernetes cluster as Knative. And then once I deploy it, and now I'm going to create the Knative source once again, which is a little bit different here. So once Knative source is, however, this is a little bit more detail here. as you can see the KEDA annotation. It allows me integrate Knative and KEDA. You don't need to develop like some application level. You don't need to specify, create a new YAML file. You just set up annotation. You can actually create a YAML file, but one of the good things as Java developer to wanted to integrate KEDA and Knative for your event-driven application. You just set it up like a computation here, like a integral power pooling, and then like a min-max, like a 0 to 10. You can set it like a 1 to 10, whatever you need. And then here's the one thing, really interesting stuff. So my Bootstrap server is a Kafka. You can set it like a messaging server or a Kafka server in the topping name, the targeting your Knative services here. Okay, I just copy it from here, and I build success, back to the topology view, and then here's my Quarkus application. In the meantime, it's already scaled down to 0, and let's try to create a Kafka source. Okay, and back to here, and then it will attach it to my Knative services here, and then now I'm going to go back to and run my job file once again. You can actually change the label. Make sure my application is based on Quarkus. It's just good to have because sometimes you need to deploy multiple application. For example, like a Quarkus Java or JavaScript or PostSQL, some of the stuff. Is make sure which runtime, which technology, which software you're going to use with the same namespace. All right. And then I'm going to try to set the application and back to here. And now we got to have a new one. And the create 5 application. And exactly, you can see it's already scaled out. It's already scaled down to 10 because it's already figured out. So in the first demo, we take some time to scale out my application to 4, and then after a couple seconds later, it scale out to 8. But however, this is pretty much faster because the reason why it's not only scale out application itself, but also scale out your Kafka and event infrastructure at the same time. This is just super fast, and it pretty much flexible because when you really give it some time, take a look at this status, your application like scale up, down, and in and out, like up and down, basically your network traffic. So once you click on one of the application view blocks here, so many things are coming on here, and then back to the pod, and the data application already scaled out to 10. So pretty awesome. And then go to here on the data 1, you can see the resume is super fast. And it will end up scaled down to 0. Once the job is done, as you can see, so your pod is almost terminating automatically, which means your application, I'm already done my job. However, but if you keep coming more application, you can see it will up and down pretty flexibly. In the end, as SRE or platform engineer perspective, we can save our resources. It will save our money, maintain our infrastructure as well. Okay, and then let's go back to like a previous thing, like a Kafka KEDA. And then as you can see, it's just, the job is done and no more traffic, and then it gets scaled down to 0. But it takes some time to finish this kind of stuff rather than KEDA Knative. But one more thing, this is not serverless based on. And then here is the KEDA Knative. And then it also scaled down to 0, just like a job is done. And then the last project, the KEDA Knative Integration. So job is still working. Once this job is done, and then your application, the serverless application will scale down to 0. It's pretty much faster than the other use cases. So this is the benefit of the KEDA Knative integration. So, but I don't want to say you need to use always KEDA and Knative integration on your production or even your staging product. So, however, if you already have a Kubernetes environment to manage your just standard application, but also serverless application using Knative. In that case, if you're really looking forward to more high performance or more event-driven auto scaling, not only standard application but also serverless application, this is a really good use case to handle that kind of stuff. And now you can see your the job is done, and then your application just scale down to 1. It will end up scale down to 0. Okay, so I'm gonna go back to my slide deck and try to wrap it up, and then I'm gonna give it some time, question and answer. So it's not only Kafka source, you can actually integrate more event infrastructure, for example, AWS SQS source, Redis stream source, and the RabbitMQ broker. As you can see, in the Quarkus side, you could set up like a different configuration here, the KEDA, and then like auto scaling, and a bunch of SQS, and then Redis, and a bunch of stuff. And then you can also create like a YAML file directly. So here's a GitHub repository. You can go to like a Kafka sandbox project, and then you can find more detailed information. So one more thing, and the last thing, here's my YouTube channel handler and a bit.ly URL, and here's a QR code. I'm pretty encouraging all of you subscribe my channel, and then I already upload a bunch of the technical tutorial and video, not only Java application, but also multiple use cases. For example, serverless function and GitOps, and then like a CI/CD, and then even fundamental Kubernetes running paths as well. And feel free to subscribe and give me some inspiration, or if you have any technical question and suggestion, just put on the chat or right now, or you can just send the messaging to my Twitter, Daniel030, or you can add some comment my YouTube channel. I'm more than happy to address that question. Alrighty, thanks for joining my session today. And any question, I'm more than happy to address today.
Okay, thank you, Daniel. Thank you for your talk. It was really interesting from my point of view. So I will make a first question. Se avete domande, scrivetele in chat, che le propongo ovviamente al nostro speaker. The first question is, what component in KEDA enables scaling, for example, deployment, stateful sets, and so on?
Yeah, that's a really good question. So as I already showcased, it's a scaled object. So traditionally, you just create an HPA object on Kubernetes to scale in and out, but this is based on CPU and memory utilization. So I don't have any chance to showcase that kind of stuff. But when you go to my YouTube channel, I already created that use case as well, which means you maybe takes like a 2 minute or 3 minute to scale out your application, but you already have like an overflow to process your event messaging from Kafka cluster or like a external services. However, in order to make it better, with the KEDA to standard Kubernetes resources, scale up and down, scale object. That is the right answer to manage your auto scaling based on KEDA.
Okay, perfect. The other question is, what kinds of Knative eventing autoscale for KEDA can you use? So which are the technologies you can use to autoscale in this case?
Yeah, that can you say it again? I just
Okay, the question was, what kinds of Knative event autoscaler for KEDA can you use? You talked about
yeah,
Kafka. So
yeah.
what about
Yeah,
Kafka, for example?
that's a really excellent question. So maybe I'm going to go back to my slide. So we have in the Sandbox project, a Sandbox project, we AWS the simple to queue services source in the Redis streaming in the RabbitMQ, not only Kafka also, but we keep creating more the events-driven sources as well. That's really interesting stuff here.
Okay. So I think your slides will be very useful. I don't know if you will share it, but I think our participant will be glad to. So thanks for your time. Thanks for your talk. And I hope to see you again in the next edition.
Yeah, absolutely. Yeah, once again, thanks for joining everybody today's session. And please feel free and don't hesitate reach out to me directly. And thanks again, Serena. And I hopefully be there in person maybe next time. I'm
Yeah,
also really looking forward to that, but I'm sorry for that. But yeah, once again, thanks for having me, even virtually. I'm more than happy to be here, and then looking forward to catching up with you in person next year.
next
And
year. Yeah,
yeah,
finger crossed for
finger
next
crossed.
year. And I will for sure subscribe to your YouTube
Yeah,
channel because I
that
already seen some videos that are very
that'll be
interesting.
great. And then have a good, wonderful day, and then have a good rest of a great day.
Thank you. You too.
Bye bye.